to be 0. So I cannot up. I don't have any input voltage. So what I should do? I should apply some voltage across the output side to measure what is the output current. Correct. So output is also open. Input signal is also the not given, means I cannot find what is the thing, right? So that is what you say. Since we have put Vs equal to 0 at the output side, I'll be exciting the output side by an voltage capital V, and I'll be finding what is the current delivered because of this voltage source capital V. So name the current to be I. So R naught F is going to be V by I. Is it clear? That is the logic we are going to be using for finding out the output impedance. And I will not have V naught. Here V naught and V are same. Because what I apply is V naught, what I measure is V, what I apply is V, what I measure is V naught. So both are going to be same. So apply KVL at the output side. So this is going to be my voltage, capital V. I am applying the voltage here. This RL is not there. So I can write the value of current to be, it is flowing between two voltages. So V minus AV into VI by R naught. So this current is flowing between two voltages and only one resistance I have. So this I is going to be, assume the current is flowing this way. So VI is equal to V minus AV into VI divided by R naught. Okay, and in the input side, Vs equal to 0. So if you apply KVL at the input side, you will get Vi plus Vf equal to 0, or Vi equal to minus Vf, and Vf is equal to beta into V naught, and V naught we have replaced it by V, so Vi equal to minus beta V. Okay, so Vi equal to minus beta V. So substitute the value of Vi in this equation. Substitute Vi equal to minus beta into V. So I is equal to V plus beta AV into V by R naught, or take this V outside, V into 1 plus beta AV by R naught. So R naught is equal to V by I, take the ratio V by I. So R naught F is equal to V by I. So if you rearrange, you get R naught by 1 plus beta into AV. So AV represents the open circuit gain without considering RL. Always remember, all amplifier parameters are computed without considering the externally added components. We are adding RL, VS externally. So those will again change the actual gain of your amplifier. So amplifier gain means open loop gain or open circuit gain. It is without your RL. So R naught F we got is R naught by 1 plus beta AV. So when you divide any number by quantity, the value will reduce. So the output resistance will decrease. And I told you, see here, output I am going to have voltage sampling. Voltage will be same in shunt. In shunt, resistance will decrease. So logically, see here, in output side, the output resistance is decreasing. So theoretically, whatever we have seen about voltage series feedback, it is being proved practically by mathematically applying KVL and KCL at the input and output side of the amplifier. We can effectively prove that whatever judgment we made about RIF and R0F are going to be true. They are not going to deviate from the theoretical fundamentals. And there is one more component called R naught F dash, and R naught F dash is going to be including RL. So R naught F dash is going to be R naught F parallel to RL. So till this it is R naught F, and I have RL in parallel. So R naught F dash will be parallel combination of these two. See here, R naught F dash is going to be R naught F parallel to RL. R naught F value we know. Substitute that and you can get the value of R naught F dash. It is including your RL. So you will be finding all these parameters when a problem is given. You will be finding out what is RIF, what is RI. You will be finding out what is R0 F, what is R0 dash, R0 F dash. Apart from that, specifically if it is an voltage series feedback, you will be finding what is voltage gain. You will be finding out AV and AVF. See, simple, what logic I'll say from the beginning, what you should do. From the name of the amplifier, to identify what will come in the input side, what will come at the output side. Voltage series feedback, input side series. So I'll be having Thevenin's theorem. Output side voltage. Yeah, I'll be having voltage source at the output side. So accordingly, you can first draw the diagram. Remember, VI is the input given to the amplifier, and II current is what is going to the amplifier. And AV into VI and R naught are the standard components which will come for an amplifier. And I'm connecting externally RL, and across RL I'm measuring V naught. If I measure output resistance, it is going to be before RL. After RL, it becomes R naught F dash. And current coming out of the amplifier is I naught. And since it is series mixing, the voltage is mixed at the input side. Voltage is mixed at the input side. And then apply KVL, KCL. It's going to be very simple. Any queries anybody is having?